This is my presentation about my individual research, temporal database. First, let's talk about what is temporal database. Temporal database is a database that stores the time. But someone will ask that the current database management system can also store times. What's the differences? The differences is that the most RDBMS store and query time only with the date or timestamp. They focus on the time slot. But when they want to store something that is called time period, they will get some problem. For example, now I want to store the record that indicate the price from January to April are all 4. So it will take 4 rows to reckon this one record. First, it has some problem. First, it is not efficiency. It wastes a lot of storage space. Second, it will be slow because when we want to do some aggregate, the database have to read multiple rows. And last, it is really hard to modify the time period because sometimes when you want to do some update, you need to update the 5 column or 4 rows. It is really a difficult thing. So for the research history, the research about temporary database is beginning really early in 1980s. But however, only in recent years, few commercial database management system has implemented some functionality in these ways. And in December 2011, SQL 2011 is published to implement this new function to manipulate temporal tables. So I will talk about something in SQL 2011. Next part, temporal database and current practice. So now I talk about something about current practice, the current workaround. In this day, most database manage the time period in this way. They use one column, which is called begin time, and another column, which is called end time, 2 columns to store the time period. This one means the time period from January to April. But this implementation, this workaround, also has some problems. First, edge case. Edge case means for this record, I don't know it include January or not. I don't know it include April or not. This is the edge. So for the edge case, user needs to define this business rules for this edge case. It's not convenience. And the second one is primary key integrate. And the last one is suitable index. I will talk about it later. First, the edge case. In SQL 2011, the time period is defined with a closed open model, which means that the time period include begin time, but not include end time. For example, in these 2 records, is simple example. We know that April, the price for April is $5 because the second one record include the begin time, but they don't include as end time. So in May, I don't know what happened in May. This is something called this closed open model. And the second part, temporal entity integrate. This one you can see in this simple example. 2 time period overlap and duplicate records for April. It means that for first record, it begins from the time period begin from the January to May. But however, in second record, it begins from the April to June, and it overlapped in April's. So in this one, it's a mistake for April's. The first row indicates it is $5, but the second row indicates first row indicates the dollar is $4, and the second row indicates it's $5. And this one is something called the mistake. But however, traditional primary key constraint is not helpful. It cannot be applied to prevent this time period overlap. But however, something new happened. in SQL 2011, this one has some new features. It extends the primary key constraint. So for this one, you will see it defines a primary key based on time period without overlap. It defines that there should be no overlap for this time period. And you will think about what is overlap means. Okay, that's my next topic. Time period operation. First one, Allen relationship. In computer science, there is a temporal reasoning that introduces an Allen relationship. Allen relationship define certain different kinds of relationship that describe all possibility of the two time period. For example, here, if A time period begin and finish before B time period, we call it A precedes B. If A time period finished and B time period begin, we call it A meet B. And for the thing that A time period begin but not finished, and B time period begin, we call it A overlaps B, something in this way. This is called Allen relationship. And in SQL 2011, this one is built on the Allen relationship, but it only defines 5 relationships instead of 13 different Allen relationships. We call it first A overlap B. This is one extend finished by, contain, during, overlaps by, start by, and equals. With all operations in Allen relationship is called A overlaps B in SQL 2011. And another SQL operation is A contain B, include 4 different kinds of Allen relationship. The same thing happened in A precede B, A equal B, A immediately precedes B. All this operation. This is 5 different kinds of SQL operation relationship. Okay, next part, static RI tree. We have talked about that in the traditional relation database. There's no suitable index for the time period. Now I introduce a new index for the time period. Okay, let's look at the previous one. The traditional index is designed for fast query for time slot, not time period. And when dealing with time period, it is not efficiency, especially for range query on composite key. For example, now I do this query. Select something from table. Select all the record from the table where the lower time is more than some time and the up time is less than some time. There will be a problem. Okay, now I introduce a new index for static RI tree. Relational interval tree is a structure to efficiently handle the time interval query in SQL. And this one is some implementation about the binary trees. But however, now it is not implemented in SQL Server. So I have to make some function to support the RI tree index operation. First, let's compare the 2 different schema for these 2 different kinds of index. In the traditional index, look at the schema. We have a lower date and up date. That means the beginning time and the end time for the time period, and some metric like money. Okay, so now we create an index on what? On the lower and upper, and also create an index based on the upper and the lower. This is a traditional index. But for RI tree, something changed. It introduced a new column named node here. You see, node is some calculate column. It's that the value for node is calculated by some algorithm. And for the index, it includes node, lower, and upper. These 3 columns to make a composite key. The node is used for improve the performance of the RI tree. It's a new design. And now I do some performance analysis. The test dataset has 10 million rows. And now we set the statics on to visualize the performance in SQL Server. And however, for query, it contains a time period. We query a record which contains a time period. The last one is a traditional implementation, and the right one is a new implementation for RHA index. And you see here, we use a function to implement some operation because this one is not implemented in SQL Server. Okay, so let's go on next. Execution plan. The execution plan is provided by SQL Server. That will help you to know what is really done by SQL Server's parser and optimizer and how SQL Server executes this query. Okay, look at first. Traditional plan. The traditional plan in SQL Server is really simple. Traditional index plan, it only uses a lower. It's only use one column to optimize the query execution. But for static RHA index, it uses the lower and the upper. The both index use all of them to optimize the execution query. So let us see some results. The performance comparison. Here is a table that tells you what happened here. In CPU time, RHA index is 20 times faster than the traditional ones. And in the logic row read, what does this mean? This means that how many rows the database read from the memory or read from the disk. The traditional index read 340 times more than the RHA index, which I see that the RHA index is really efficiency. But however, there is a trade-off. For load 10 million rows into traditional index, it only spent 3 minutes. But however, for a static RHA, it spent 4.5 minutes. So we see that the RHA will be a little slow for load. But however, for 10 million rows and for the query, we have to see here, the queries will be reduced 2 seconds, about 2 seconds for execution. So let's do some simple calculation. If we query more than 45 times, the static RHA will be more efficiency. 45 is not a big number. Many applications will run some query hundreds of times or thousands of times in one day. So in most implementation, static RHA will be a better solution. And according to the limitation of the record video, the video record software, I will introduce the last part, insert, delete, and update time period in next video. Thanks.